Hi everyone, in this video I'm going to continue to work through a grade 9 paper 2. Please let me know if you have any questions. So we jump into question 3, so they want us to match the 2D shape to the description. Okay, so we're just going to go through, see which ones make sense. So first of all, we've got a 4-sided shape with one pair of opposite sides parallel. Okay, so if you draw some sort of shape, just so you can see what's going on, and we're going to have 4-sided shape. So I'm just drawing a rectangle, it's probably not a rectangle. And we've got one pair of sides are parallel. Okay, so the only shape that is like that, or that's only got one side, would be a trapezium. Okay, so these are the properties of quadrilaterals that you just got to remember. They always ask these, so it's a good one to remember these. So we can cross that out. A 4-sided shape with 4 equal sides, equal diagonals that bisect each other perpendicularly, and 4 equal angles. Okay, so that is either it's going to be a square or a rectangle, a square or a rhombus. The reason why we know it's a square is because they bisect each other perpendicularly. They've got 4 equal angles and they've got equal diagonals. Okay, so it is going to be a square. Again, that would really trick you out if you didn't know these properties. A 4-sided shape with perpendicular diagonals and 2 pairs of adjacent sides equal in length. Okay, this one again sounds really scary, so let's just cross out. Well, we've still got a rhombus potentially. Let's just cross out the square. Okay, so 4-sided shape with perpendicular diagonals and 2 pairs of adjacent side equal in length. This is your clue. There's 2 pairs of adjacent sides. So if you have a kite, then we can say these 2 sides, they are adjacent, they're next to each other, and they equal in length. And these 2 sides are next to each other, they're adjacent, they're equal in length. So that would be a kite. Next up, we've got a 3-sided shape, so we immediately know that's a triangle with 3 equal angles. Okay, so the clue is the equal here, so that is an equilateral triangle, because that is all the angles in an equilateral triangle are 60 degrees, so they're all equal. And then finally, a 4-sided shape with equal diagonals that bisect each other, but the diagonals are not perpendicular. Okay, so your clue for that is in a square and a rhombus, they are perpendicular. So the only other option we have is a rectangle. Okay, if we move on then, 3.2, so we are given we're given a huge triangle here. They want us to try prove that this top triangle here is similar to this triangle. Okay, that symbol like that means similar. Okay, so for similarity, if you wanted to prove 2 triangles are similar, you need to find that all the angles are equal, or you need to find that all the sides are in proportion. Okay, I think the easiest one here is going to be the angles, because we don't have that many sides. So let's just go through, see which angles we know are definitely equal. So we can see in each of these triangles, we've got a right angle. Okay, so that's our easiest one. Those are definitely equal. So we can say T1 is equal to D2. Okay, that's the angle. They're both equal to 90 degrees, and that is given to us. And then let's see what else we can find. So we could say okay, so it's a little bit difficult to see. Let's get a different color pen so we can see. Because we got a rectangle here, it's kind of an interesting situation. So because we got this rectangle, they're joint tell us, but that means that these 2 lines are parallel. Okay, which means we can use maybe corresponding angles, co-interior angles, alternate angles. What we've actually got here is, like I said, it's a little bit difficult to see at first, is we've got corresponding angles, because we can say then that this E1 here is equal to angle S because of that F shape. Okay, so it's an upside down F, but it is an F shape like that. So we could say that angle in there is equal to that angle in there because of corresponding angles. You just have to give quite a good reason now. So we have to say E1 is equal to S. The reason is corresponding angles. And then when you give that as your reason, you always have to say which lines are parallel. So TE is parallel to AS. Okay, so you're just giving this line is parallel to that line. Okay, when we're proving similar triangles, if we get to this point where we have two of the angles and each of them are equal, that means the last one has to be equal. So this last angle, let's just put a star next to it, this angle W has to be equal to angle E2. And that would just be because if you added up the angles in the top triangle, added up the angles in the bottom triangle, if you used some of the interior angles, they would have to add up to each other. So you'll find this happens a lot. So if you ever get to a point where you've got two of the angles, you've proven them are equal, the last ones have to also be equal. So then you can just say, okay, so angle W is equal to angle E2. And your reason is going to be the sum of interior angles of a triangle. Okay, then we're nearly there. So we've always got four things that we've got to write down for similar. So we've got to prove the three angles are equal. And then the fourth thing is we're going to say then, therefore we know that triangle WTE is similar to triangle EDS. And our reason is you can write it like this, so angle, 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 or you can draw it like this, angle, angle, angle. Okay, there's our 4 marks for that one. And then we know that if they are similar then the sides are in proportion, which means then we can complete this proportion statement. So all we need to do, let me get rid of some of this drawing on here so you can see what's going on, is we are going to write down the corresponding sides. So first of all, we got 4 over something. Okay, so the 4 is in that top triangle. So let's just get a green here. Okay, so that is this line here. So 4, it is the line that's kind of attached to the perpendicular one. So that 4 is going to be this corresponding one is going to be this one in that triangle. Okay, which makes sense. You can see it's in the same position. So we're going to say 4 over y, and then x, let's just check where that one is. So x is this bottom one. So that is going to be the same as this 3. So it's going to be x over 3. So you just write whichever one, you just write it over each other. So you just check, this is what I've got in the first triangle, what do I have in the second triangle? And then they say, okay, because of that now, they just want you to work out then what x, y is. Okay, so if you have something like this, 4 over y is equal to x over 3. Kind of a funky trick you can do is you can times across. So you can go x times y and that times that. Okay, so what you're going to get is x times y is xy, and 4 times 3 is 12. And that's what they wanted you. So xy is equal to 12. Finally then, they say, because we've got this now, they want us to calculate the area of the rectangle TADE. And actually, we have already done this. So it is quite strange. If you look at that rectangle, this is what the rectangle looks like. So we've got the one side is x long, the other side is y long. So the area of a rectangle is always the length times the width. Okay, so in this case, we would go x times y, okay, which gives us xy. And so we've actually already worked that out. So our area of this rectangle, xy, is 12 centimeters. And just remember, put it in, I don't actually know if it is centimeters. Let's just check. No, so they didn't actually tell us the centimeters. So don't put the centimeters, but you do need to say units squared because area is always units squared. So 12 units squared, the little square at the top for area. Okay, then we've got 3.3 in the shape below. So angle A, so it's always this one in the middle that they're talking about, is 117. So they tell us that. Angle F is 133. So that's that one. And angle G is 37. So that's that one. So they're just telling us what's already on the diagram. Determine with reasons the size of alpha. So we're trying to get this one on the top here. Okay, so what you got to do in a question like this, you can see it's lots of marks. So we're just going to work out as many angles as we possibly can. So what I would do first is I'm going to get, let's say, this angle up here. So I'm going to just label this 1, and I'm going to work out A1. Okay, just label it nicely so they can read it, so then they can check, okay, that's A1. So I'm going to say angle A1 is going to be 180 take away 117. The reason being, we can see here, this is actually angles on a straight line. So put your reason in, because that's another mark there. So angles on a straight line. So if we go 180 take away 117, we are going to get 63 degrees. Okay, you can then put that in there to help you. So A1 is 63. Sorry. We've just worked that one out, 63. Then let's work out F in exactly the same way. So I'm going to say this is F1. Again, we've got angles on a straight line. Okay. So we're going to say F1 is 180, take away 133, which is going to give us 47. And again, angles on a straight line is your reason. Put it in. I know it's tedious to write it down, but they do give you marks for that reason. Then we can fill that in there. So just fill it in because it helps you to keep track of it as well. So we've got this one is 47. Sorry. Just loading for us a bit. There we go. Okay, so we've got this one is 47 degrees. I know it is really roundabout, but we are getting close to the answer. So what I would work out then is I would work out this one. So H2, this is H1. So I would work out angle H2. And the way that I would work that out is I'm going to be looking at this bottom triangle here. Okay, sorry for my chaotic drawing. So in this bottom triangle, we have got 2 of the angles. We just need that last one. So we could use angles on a triangle. So we can say H2 is going to be 180, take away that 37, take away the 47. So H2 we can work out then is 96 degrees. Our reason is the sum of interior angles of a triangle. So triangles always add up to 180 degrees. Then we've got to use the fact that H1 and H2 are going to be equal. This is sometimes something they try to trick you with. The reason is we can see here, actually, these are vertically opposite angles. Okay, so we can say H1 and H2 are equal because of vertically opposite angles. Okay, so I would just say vertically opposite angles are equal. Okay, and now we are finally getting there. We're at a point where we can work out that alpha. So we're going to be looking in this top one. So we are looking here. Nope, sorry, that's not going to work with the highlighter. Okay, we are looking in this top triangle. So let's just get circled so we can see where we're working. So we're working in here now. And what we are going to say is, again, angles on a triangle, because we've got this angle, we've got this angle, and so we can work out alpha. So alpha is going to be, again, 180, take away that 63 in the corner, and then take away what we just worked out, which is H2 is 96. Okay, and then we are going to find that alpha is 21 degrees. And our reason, again, is the sum of interior angles of a triangle is 180 degrees. Okay, so a lot of work, but you can see here we've got 4 things that we've worked out. Okay, so let's just show you how they're going to mark this. So they're going to give you a mark for A1, a mark for F1, a mark for H2, and then a mark for your alpha. So that's 4 marks there, and that would give you half marks here for your workings. So in the end, you're going to get 4 marks, or 6 marks in total. Okay, so very tedious, but if you are really stuck like that, just work out as much as you can, because you will get marks even if you don't get a final alpha. Okay, question 4, you're going to have to deal with my really bad drawing again. So draw the image of A, B, C, D, F. So they want us to draw the image of this shape, translated 5 units to the left and 6 units upwards. So translated just means moved. So they just want us to move it 5 units to the left, 6 up. Okay, so let's do that first. What I would do is I just move each point. So I'm going to say A. Let's move that one 5 to the left, 6 up. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That is going to be where my A is. Then F, same thing. We can use a different color. You'll get the hang of it. I think most people find this quite easy. So F, we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then we've got F there. Okay, so that's how you move it like that. Once you've got 2 points, you can generally just redraw the shape then. So I'm just going to get rid of the scribbles so we can see. So then I would just draw it then. So let's get a different color. So it is 1 across like this. Then we've got 3 down. So 1, 2, 3. Again, apologies for my drawing. 1, 2 across, up, like that, and like that. Okay, and then just label it. So when it's translated, you just put these little apostrophes next to it to show that it's been moved. Okay, and then E and D. So that's all they want you to do. So nice, easy mark, just redraw that shape. Obviously yours would be a little bit straighter because you're going to use a ruler. Then we've got this shape. So they're the vertices of a triangle. They want you to write down the coordinates after we reflect it in the y-axis. So what I would do is I would draw that triangle to start. Okay, so we've got A1, 2. So when x is 1, then y is 2. That is our A point. Then when x is minus 2, y is 3. Minus 2 and 3. And then, okay, so that's our B point. And then C is minus 4, minus 1. So when x is minus 4, y is minus 1. Okay, very strange triangle, but that's fine. Okay, so then we can connect our triangle. Okay, so sometimes it's difficult to see these. If you're reflecting it in the y-axis, what happens is everything, all the points just flip over the y-axis. Okay, so let's get a different color pen. So if we get this pink pen, so if we reflect it in the y-axis, means we flip it over the y-axis. So A is going to be exactly the same level. We're just going to draw on the other side of the y-axis. So it was 1 across on this side. Now it's going to be 1 across on this side. So that is going to be our A now. Okay, that's going to be our A. Then we do the same for all the other points. So C was 4 across on this side. Now it's going to be 4 across on this side. So that's going to be our C. So we're just flipping it, we're just taking it across the y-axis. And then B was 2 across here, so it's going to be 2 across here, but the y stays the same, okay? So it's at the same height. And then we just redraw this one, okay? So you can see it is flipped now. It's like a reflection across the y-axis. All they want us to do is write down the new coordinates, okay? So we're just going to read off the new coordinates. So A, remember, when it's translated or reflected like that, put the little apostrophe. So A has now become, x is minus 1. So you just read off x is minus 1, and then the y is still 2. The B coordinate now is x is 2, y is 3 still. And the C coordinate is x is 4, and y is minus 1. Okay, so a little bit strange, takes some getting used to, but that's what it is. The other way you could maybe try to think of it is if you're reflecting in the y, the y value stays the same, but the x, just the sign in front of it's going to change. So we can see here, it was 1, it became -1. It was -2, it became +2. And it was -4, it became +4. So you can say, I was reflecting on the y, all I change is the x. But sometimes it's easier to just draw it like that and see. Okay, then we've got a cube with a length of 7. So a cube, they like to try trick you. If it is a cube, that means the length is 7, the width is 7, and the height is 7. Calculate the perimeter of the base of the cube in meters. Okay, so the base is the bottom part. It's the same as the top. And how the base would look is it's just a square, and it is 7 centimeters by 7 centimeters. They want us to work out the area or the perimeter of the cube in meters. So what I would do is, instead of that centimeters, I'm going to say 7 centimeters divided by 100 is going to give me 0.07 meters. Okay, and I'm going to just work it out in meters because that's what we need. So the perimeter, let's get this drawn on here. Perimeter is if I was walking around the edge of this whole shape. So 0.07 meters there, 0.07 meters there, 0.07 meters there, and also here. So the perimeter is I walk around all those. So the perimeter, I would just add those all up. Okay, so the perimeter is just going to be all of those added up. So you can go 0.07, add 0.07. You can do that, or you can just say times 4. And we are going to get 0.028 meters. And it stays meters because it's not perimeter or anything like that. Sorry, 0.28. We don't need that extra 0. You have your calculator, so you would be checking that as you go. Calculate the area of the base in centimeters squared. Okay, so now we want centimeters, so they want the area of the space in centimeters. Okay, again, that's our base. Area, we remember area of a rectangle, area of a square is always just length times width. So here we've got a length of 7, a width of 7, and so we're going to get 49 centimeters squared because we went centimeters times centimeters, so we've got a little square. Area is always a little square. And then finally, calculate the volume of the cube. Okay, so volume, how I always remember it, is the volume is the area of the base times the height. Okay, so we've already worked out the area of the base. We said the area of the base is 49. We did that in 5.1.2. And then we times it by the height of the cube, which is 7. And let's just see what we get for that. So that is going to be 343. And volume is always cube because we times it technically by 3 things. Because the other way for volume is you can say volume is always length times width times height. Okay, so we times 3 things. That's why we get a little 3 at the top. Okay, and then calculate the surface area of the cube. Okay, so surface area is if I look at this cube, I want to know the area of every single side. Okay, so I'm going to say, okay, the area of the front side, the area of that side, area of that side. I'm going to work out all of the areas and then I'm going to add them all together. So we know on a cube, all the sides are the same. So we know every single side looks like that one that we worked out, which is 7 and 7. Every single side is like that. There are 6 sides. So we can say, okay, the area of one side is 7 times 7, which is 49. If we want the area of 6 sides, that is just going to be that answer times 6. So 49 times 6, which is going to give us 294 centimeters squared. And then they always work this into the question somehow. At some point in a question paper, they will ask you this. This is in centimeters squared. They want it in meters squared. So you just got to be careful because of that little square up there. If you convert into meters, usually we would divide it by 100. But because it's got that little 2 up there, we have to go divide it by 100 and divide it by 100 again. Okay, and we're going to get 0.0294 meters squared, and they said round it to the nearest meter. So this rounded to the nearest meter is actually just going to be 0 meters squared. Okay, which is a strange answer, but they're just checking that you can do that conversion. So remember, centimeters squared to meters squared, you do what you would have done. So you divide by 100, but you have to do it twice because of that little square. So divide by 100 and divide by 100 again. It would be the same if you're going from centimeters cubed to meters cubed. Because of that little 3, you're going to divide by 100 3 times. Okay, and then let's do one more question here. So we've got a cylinder with a diameter of 28 and a height of 35. It can fit exactly into this square base pyramid. Okay, they kind of tell us this. I don't know why they tell us a square base. Sometimes it's just to try confuse us, because they just want us to calculate the volume of the cylinder. Okay, which volume of the cylinder, we don't really need to know anything about the square. So volume of any shape is always the area of the base times the height. Okay, the area of the base of the shape, so the base of this is the circle, okay, because that's what it looks like on the bottom as well. Okay, and to find the area of a circle, you have to know this formula. So the area of a circle is always pi times your radius squared. Okay, in this case, they give us that diameter, so we would have to first of all work out the radius. So the radius is half of the diameter. So it's half of that. So it is going to be 14 millimeters. Okay, so then you could work out that's going to be pi times 14 squared. So you can work that out then. And then once you work that out, you're just going to say pi times 14 squared times your height. So the height of the cylinder, they tell us, is 35. Okay, so we could then work that out. Just be careful, they tell us to, instead of using pi, we're going to use this 22/7. So you're going to put that into your calculator. 22/7 times 14 squared times 35. And you should end up with something like 21560 millimeters cubed. Okay, I really hope that video helped. I'm going to be posting some more parts, but please let me know if you have any questions in the meantime.